all of us aware of this regenerative agriculture these days. And so I'm not going to detail of what is regenerative. It's a holistic farming approach. And it's facilitate practices to improve, the soil health, encourage biodiversity, promote water efficiency, and reduce greenhouse gas emission. And at the same time, support farmers to diversify incomes and become more resilient to climate change. In case of CottonConnect, we have a very comprehensive, uh, uh, discussion over the last couple of years why we were developing this program. So it is based on four major components. That is the soil health, then the climate change, biodiversity and ecosystem services. You can see the right side of the slide. And then we have a resilient livelihood and the ecosystem. If we look at this regenerative program, based on my experience of last almost, maybe 20 years at least, not 35 years, I'm working very closely with the farmers and at the very grassroots level. And, we have now developed, a regenerative house actually. So it should be a very comprehensive. It should contain everything. And we call it a real regenerative house actually. What is real? Real is our flagship program. It's a responsible environment and enhanced livelihood. This is our flagship program. And under this program, we have this regenerative house. And if you look at the foundation of this house, it is the biodiversity. We talk about biodiversity because this is very important. Without biodiversity, I think we thinking of it, soil health is just a dream actually. So when we talk about the agrobiodiversity, it is improved soil health actually. We're trying to improve soil health with the help of this biodiversity, retain habitat, and increase productivity. If you go slightly upward, the next step is the ecological infrastructure. It's very important for regenerative to promote agroforestry, increase crop diversification, and mimic nature on farms. Actually. So this is a ecological infrastructure, and then comes the main pillar of the the implementation of regenerative agriculture is a soil health. Under soil health, we talk about a number of things. So I'm not going to detail, but this includes crop rotation, the soil organic matter improvement, composting, reduced tillage, then water protection is very important, utilization of water, wisely, and as per the requirement, disease control, and then there's a social fairness. I think without social fairness, without talking about the farmers, and particularly the smallholder farmers, we cannot implement this, and there's no benefit for the regenerative agriculture. And then on top of it, if we talk about the impact, actually, the livelihoods improvement, build resilience, diversify income, and adapt to climate change. So this is a house, and we normally follow this house while we implement the regenerative program in the field. At the same time, to support this house, we have a theory of change as well. So it is basically a three major component that it includes. That is if we talk about the farmer resilience, and when we talk about the output, it is a training and awareness creation, regenerative practices, institutional development, access to capital, labor rights, and gender. So this is a kind of including both the crop environment and the farmer and farmer families actually. And then if you look at the outcome, this is improving the farming performance, supplement farm benefits, enhance social fairness, and most important is the secure supplies actually. So this we then, when we talk about the farmers and implementation of real regenerative at the farm level, it is not just farm level, it includes everything from the farm to the end product to the shelf actually. So supply chain is the very integral part of this program. And then if we talk about the climate adaptation, the output is carbon sequestration, water management, forestry on farms. And when talk about the outcome is the foster climate adaptation mitigation. And in case of, the biodiversity, and when we talk about the biodiversity, it is the drive, you know, responsible land management that helps biodiversity flourish. It is the, if we talk about the output, is the holistic farming, creation of habitats, protection of species. So again, I would like to stress that biodiversity is the basic for us in case of regenerative agriculture. If we look at the core principles of the regenerative agriculture, there are normally six core principles. So I will skip the first one. If you look at the 5 core principles, more or less they are related with the soil health actually. So the first is the minimize soil disturbance. The soil is the target. Second one is the maximize crop diversity. So again, indirectly addressing the soil. And keep the soil cover, directly talking about the soil. Then maintain living root, again, directly talking about the soil. And then we integrate all these things with the livestock. So this interaction between the soil and the livestock is very important. Soil is producing the fodder for the animal is consuming that fodder, and the farmyard manure is coming back to the soil. So this relationship is very important in case of the regenerative agriculture. So in case of our program, we have a very strong focus on this interaction between the livestock and the soil health. So what is soil health basically? Sorry for going to very basic, but I think to develop this story, it is very important to have this, all these things in place. So when we say soil health, the soil health is the continued capacity of the soil to function as a vital living ecosystem that sustains plants, animals, and human beings. And under this soil health, there are 5 subcomponents. The nutrient cycling. Soil health is responsible for this nutrient cycling, water infiltration and availability, filtering and buffering, physical stability and support, and habitat for biodiversity. Again, the biodiversity is focus of attraction in case of the soil health. If we look at the soil biodiversity, I know these are very readily available information, but just to share with you, 1 gram of soil contains 1 billion bacteria cells. This is in case of a normal, healthy soil. Talking about the normal, healthy soil. 10,000 different bacterial genomes within 1 gram of soil. Thousands of different microbes and small animals, including nematodes, earthworms, and mites. So talking about the 1 gram and having a lot of this biodiversity, and if I look at the overall 1 hectare of soil contains the equivalent in weight of 1 cow of bacteria, 2 sheep of protozoa, and 4 rabbits of soil fauna. So this is how, when the soil is healthy, this healthy soil contains all this, having all these colonies of all this biodiversity. However, the situation is not like that. In globally, if we look at the map on the right side, and if you look at the area with red color, this is the area which is having a serious soil health concerns, and the area with a kind of a yellow sort of thing, area of some concern, and only the green area is the stable soil. So if you look at this map, you see this is a mostly populated area, and this is the area which grow most of the cotton actually. So this area is having more soil health related issues globally. So what are these issues? These issues are soil erosion, soil organic carbon loss. This is a big issue and is becoming a more uh, 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 a bigger issue in near future as well. Nutrient imbalance, soil acidification, soil contamination, water logging, soil compaction, loss of soil biodiversity. And the issue that I would like to raise today is the soil pH actually. So when we talk about the soil, we always talk about the soil as a soil, and we never discuss the individual component of the soil. And until and unless we look at these character or these feature of the soil, for example, soil biodiversity, soil macro and micronutrients, soil pH, soil organic matter, soil electrical conductivity, soil saturation. So all these different components have a very important role to play in soil, maintaining soil health. But these factors or components have never been taken individually to address the soil health issues. So let's talk about soil pH today. So what is soil pH? Everybody knows what is soil health. So pH is a gauge that measures the concentration of hydrogen ion in a substance. Stand for potential hydrogen. So pH is a potential hydrogen. pH is a measurement of the acidity or alkalinity of the soil. It is measured on a scale of 1 to 14. For most plants, the ideal pH level is between 6 to 7. For cotton, it is pH of 6 to 7 as well, with 6.5 being the optima. So if you look at the acidic soil, if it is less than 6, it is 5.5, 5, the plant is not able to take most of the nitrogen. So the soil is having biodiversity, soil is having organic matter, but soil is not able to take up the nitrogen fertilizer from the soil if the soil is acidic. Similarly, in case of alkaline soil, it is very difficult for the biodiversity to survive in the alkaline soil, and it is very difficult for the plant to take most of the nutrient from the soil. So this is what is happening these days. So our focus is everywhere. You go everywhere, the farmer is just focusing on putting more and more fertilizer, more and more nitrogen, more and more diammonium phosphate, more and more ammonium nitrate. So macro and micronutrients are being used to overcome these soil health issues. So if you look at the soil profile, we divide the soil profile into 3 parts. A is the horizon. A is containing the topsoil as well. Then B, second level is a B, and third is the third level. The topsoil should be of most concern since the pH here matters most for crops. Ideally between 6 to 7 for most optimum nutrient uptake, maintain soil organic matter, and decomposition process. So only pH is playing its role in nutrient uptake, maintaining soil organic matter, and decomposition process. In Turkey, the farmers they come, they mulch every cotton stick in the soil, but their pH is not stable, so they are not getting the benefit of that, the biomass mulching in the soil. So some layers in soil have higher concentration of organic matter, which is crucial to prevent change in pH. So we have to have some relationship, we have to have some interaction between various components of the soil. For example, between organic matter and pH and electrical conductivity, pH and the soil structure. So all these interaction, all these relationships have to be maintained very healthy to have a healthy soil. So if you look at the soil health in seed germination, I just give you one example about, in case of we have a disturbed pH, it have a very serious impact on seed germination. Soil pH can influence retention of organic matter and soil water holding capacity. So pH is responsible. If pH is acidic or alkaline, it has impact on organic matter and water holding capacity. Extreme pH levels can cause accumulation of toxic elements like aluminum, the heavy metals, and the magnesium, which inhibit seed germination and damage seedling. And poor soil health can impact carbon sequestration as well. So just one factor within the soil, that is pH, have this much impact on the first level of the cotton cultivation, that is the seed germination. It affects the enzyme activity. You can see here enzyme activity. It affects the nutrient availability. It affects the microbial activity. It impacts this pH, impact the overall soil structure, plant residue decomposition. And then if there is no decomposition, then there is an impact on the humus formation as well. So this is how the pH is impacting all the vital function of the soil. So we have to have a pH. We have to have focused approach to manage soil pH. Look at this biodiversity. Soil pH has a significant impact on soil biodiversity, affecting the composition and functioning of soil microbial communities, plant root system, and soil fauna. So if the pH is not stable, nutrient cycling and decomposition is affected, pathogen suppression is affected, microbial diversity is very much disturbed, and soil fauna is also disturbed. So because of just one factor, the pH is impacting that much the soil health, and it has impact on the crop growth as well. We believe that more fertilizer mean more good crop, but this is not true actually. If we are able to manage the soil health, and maybe just one factor of the soil health at pH, we can improve the nutritional availability, nutrient availability to the cotton plant. Plant uptake can increase because of a neutral pH. The plant uptake of the fertilizer can improve. Microbial activity improve. As I mentioned, if the nitrogen fixation bacteria is impacted because of pH, then the nitrogen is not available to the plant. Then a chemical reactions, cations, the ions which are taking place. This is the electrical conductivity within the soil that is responsible for this relationship between the soil and the plant roots, and the uptake and the evaporation and the everything, and fertilizer efficiency. We are using more and more fertilizer every season without having much impact on the yield, because the basic factors which needs to be improved is the soil health. And within soil health, if we just focus on one factor, pH, we can manage, we can improve the fertilizer efficiency. So it is affecting directly this situation. This situation is impacting directly the farmer smallholder resilience, deteriorating soil health, loss of soil biodiversity, poor soil structure, low seed germination, utilization of synthetic fertilizer in large quantities, low nutritional uptake, and inefficiency of synthetic fertilizer. And resultantly, there is a low seed cotton yield, less economic benefit to the cotton farmers, directly impacting the resilience. A key impact is the poverty prevails. And this is what is happening with the smallholders all over globally, because I can give example from Pakistan. This is what is happening with smallholders. In Pakistan, we are having more than 80% of the farmers, cotton farmers, they're smallholders. They are facing the same problem here. We are trying. The CottonConnect is working very closely with these farmers. As you mentioned, Anna, that Reed is here, Shahid is here. Shahid is our local partner. So we are working very closely with the farmers. Similarly, we are working very closely with with farmers in India, in Bangladesh, in China, in Turkey, in Egypt. And we are trying to improve these basic necessities. It's just it's not, it is not necessary that we have to go for increasing the use of fertilizer, increasing use of the input all the time. No, if we can improve these basic necessities of the soil health, we can improve the efficiency of the soil. So we have to rethink about soil health management strategy through the angle of pH value, an interdependent relationship between soil pH and biogeochemical process. Soil pH influences many biogeochemical processes, whereas some biogeochemical processes influence soil pH as well. So this is a interdependency on each other. So this is an interaction that we are trying to develop. So pH controls the biology of the soil as well as biological processes. And if we look at this diagram on the right side, you will see that some of the factors which are directly influencing the pH, and some of the factors directly influenced by the pH, but there are some, both are having the kind of a intercordial relation where they're benefiting each other. So this is a biodegradation of organic pollution, which is, soil pH is helping directly. Rhizosphere process, organic amendment, it is both ways. Dissolution, organic matter, heavy metal, this is one way, and pH is, supporting this thing. Nitrification and denitrification, both way. Microbial, the ecophysiological is one way. It is impacting, pH is impacting this thing. Soil enzyme activity is again impacted by the pH. Precipitation, organic matter and heavy metals, it is again affected by the pH. Ammonium volatilization is again impacted by pH. So there are many things which are impacted by pH, and pH have a negative impact. If the pH is more, pH is less, acidic, alkaline, it has a negative impact on these things. So this relationship has to be improved. And I think this is very important that we share that we are trying to integrate these regenerative cotton practices to the smallholder farmers communities, cover cropping, reduce tillage, crop rotation, agroforestry, green manuring, use of composting, vermicompost, biochar, and biofertilizer, and balanced fertilizer. We are working, as I mentioned, very closely with these smallholders and promoting these practices to improve the soil pH. Plus, we are also having a demonstrations on, using, the lime, using the sulfur to decrease the pH, lime to improve the pH. So these trials are being done with the farmers. This is very surprising for you guys. You are already aware of it, that farmer is focusing the DAP, diammonium phosphate, the nitrogen fertilizer, but asking him to use lime to improve your pH, he or she is reluctant. So we have to demonstrate. Similarly, if pH is high, we say use sulfur, and then the farmer is again reluctant to use the sulfur, which is not costing that much as compared with the diammonium phosphate fertilizer and the ammonia. But I think the demonstration that we are doing will bring farmers to these practices. So if you look at the CottonConnect approach, it is based upon a 6-component: the innovative, practical, regenerative practices that are nature, science, and context-based. So we are developing in consultation, in collaboration with farmers and with the research institutions to develop these practices, the regenerative practices. Then our focus is on the right side. If we go on the right side clockwise, it is a focus on women and smallholder farmers, has direct access and trusted relationship with thousands of farmers in Pakistan, in India, in Bangladesh, in China, in Turkey, in Egypt. So we have a direct contact with these farmers, robust, credible verification system. Yes, when we implement something, then we have to have the verification, a strong credible verification process in place. We have a 3 level of verification. One is the first level of verification done by the farmer, by the local partners. The second verification is done by the CottonConnect itself. And third verification is done by the third independent party. Then we have a bottom-up approach. We don't go for top-down approach. No, we are not going to come up and say, use this thing. No. It is a bottom-up approach. And training, demonstration, as I mentioned, trusted relationship, hand-holding, and capacity building of farmers with the support of local partners. So it is always a kind of a bottom-up approach. Problem is coming from the bottom, and the solution is being developed. A science-based solutions are being developed. Train the trainer model to maximize good practices. And then we have a layer of traceability, as I mentioned. Traceable provide end-to-end traceability as the cotton moves into the supply chain. So we can trace the cotton from farm to the end and to the shelf. Actually, this system is very, very, very transparent, very robust, and it is being successfully used in the different regions that I have mentioned. So this is the last slide. My experience is that, in case of regenerative farming, farmers actually realized the other options available to handle some of these basic issues, as I mentioned, the pH, the organic matter, the electrical conductivity. So these other options fascinate farmers, and farmers, they are willing to use these practices, regenerative practices, because it reduces its cost. It reduces use of the fertilizer. It reduces use of the pesticide. It reduces use of the water, and it gives more economic benefit to the farmers in return. And at the same time, we are having a more environmental benefits as well, the ecosystem benefit as well, having more biodiversity in the soil, in the terrestrial. We have an agroforestry system where we work very closely with the farmer to manage these agroforestry in a way to enhance the ecosystem services.